So for this one, I think we're going to combine the equations. Okay, so this will be fun. We have iron. So we already have the given for the resistivity here. So let's have the diameter first. So 2r. So this is a given. R is equal to our value 2.3 femtofarads. 2.3 femtometers, sorry. That will be 2.3 times 10 raised to negative 15 meters. Okay, and then we have length, which is 56 millimeters, is equal to 56 times 10 raised to negative 3 meters. Okay, we have voltage, which is 220 volts. Then we have passing current having a time of 76 seconds. Okay, then lastly we have the resistivity, which is 9.71 times 10 raised to negative 8 ohm meter. So for our required, we're tasked to look for the amount of charge that's passing. Okay, for our equation, we're going to utilize 2, so this will be R is equal to V over I, and then we have R is equal to rho L over A. Okay, so let's derive that. So what would happen is, I'm going to write it here. Okay, so that will be V over I equal to rho L over A. So for our A, we're just going to replace it now with pi r squared. Okay, so it's easy to eliminate 2r here. So you can just place or find the, what do you call this? I mean, divide this to 2 before substituting. Anyway, let's continue deriving. So we want I to remain on one side before dividing it with T. Okay, so we can proceed with QT. So this will become pi r squared times V equal to I times rho L. Okay, then we can now convert I to QT. So that will be Q over T. So it will make us see which of the variables should be transferred on the other side. Okay, so we can divide this by rho L. Okay, so you can cancel this and this. Then of course, since this is on the denominator, right, this is on the denominator, so you can just multiply it here. So voltage times time. Okay, so there you have it. So our formula for this one will be pi r squared times pt divided by rho L. So you can now proceed on substituting. Okay, so that will be Q equal to pi. Then we have we want to divide the value here first by 2 before squaring it, so I suggest you do that. So that will be, what's our value? 2.3. So we have 2.3 times 10 raised to negative 15 meters divided by 2 to be squared. Okay, so this is 2r over 2, so that will be r. So it will look like this. Then this is of course multiplied by voltage is 220. Then we have time, which is 76. Then that's divided by rho, which is 9.71 times 10 raised to negative 8 ohm meter. Are we copying this right? Okay, multiplied by L is 56 times 10 raised to negative 3 meters. There. So it's guaranteed that you're going to have coulombs as a unit. But of course, if you are unsure, I can at least show the derivation of the units here. But first, let me show the cancellation for the other units. So you have meter times meter here. So that's meter squared. Right? Then you have, so you can cancel this. So what's the remaining unit? You have voltage, time, and ohms, right? So for this one, you can just use Ohm's law, right? So unit for Ohm's law, so you have V is equal to IR, right? Then our unit for this, we can retain voltage. Then you have I, which is Q over T, right? Multiplied by resistance. So you can see here LVT over Q, VT over R is equal to Q. As for the cancellation of units, you can convert this to units. Then let's see where we could cancel to show you the unit of what do you call this? Charge. So for resistance, you can write this in terms of V over I. Okay? So for you to eliminate voltage, so this will become V equal to QT over IR. Hey, wait, R is V over I, right? So since these are both numerator, you can cancel this one out. Okay? And then you can have now I, which is what? Q. So this will become Q over T equal to 1, since we cancelled V already, times 1 over Q over T. So you can reciprocate this, which will become 1 is equal to Q over T multiplied by T over Q. As you can see, you can cancel out each other, which shows the value 1 is equal to 1, which shows that this derivation will work. Okay? So there you go. You can now proceed on substituting this value on the calculator to find the final answer. Then lastly, for guided practice 4. Okay, so this is a bit easier compared to the last one. So we have even of 4.5 volt battery, right? Oh wait, I forgot the, there you go, 4.5 volts. Okay, so we have a resistance which is 1.5 ohms. Okay, so we're asked to look for the electrons. Okay, so that's number of electrons. So for this one, of course, you're going to utilize Ohm's law, so V is equal to IR. Then we can rewrite V over R equal to I. Okay, then wait, there's still per minute. Okay, so we have a given which is time, which is 60 seconds. Okay, so we can write this as V over R is equal to Q over T. Okay, then Vt over R equal to Q. Now, Q is the total amount of charge. So what we're asked is number of electrons. So you can write Q as Q sub T. So let me write that. Okay, and then we can reduce this by finding that qt equal to, number of e, okay, equal to qt divided by q sub charge of each electron. Okay, so to show you the solution for that, you can rewrite it as this. So you have here, so that's Vt, so that's 4.5 volts multiplied by, wait, so rewrite this as qt first. Okay, so this will be 4.5 volts multiplied by 60 seconds divided by R is 1.5 ohms. Okay, and then the answer for this one will be something that has a unit of coulombs, right? Then for the number of charge, or in this case number of electrons, you're just going to divide q sub t divided by 1.6 times 10 raised to negative 19. Then of course you're going to cancel the units here, leaving you with a unitless answer, thus satisfying the required, which is number of electrons. Okay, so number, when of course counting numbers, those are what do you call this? Unitless. Okay, so there you go. As for the self-paced, you're going to see them on, of course, our Canvas courses, and then at the same time you'll be seeing examples to solve that involves color bands, which of course will be discussed to you by your teachers. Okay, so as a preparation for our next meeting, kindly prepare yourselves on circuits that involves, of course, resistors that utilizes series and parallel connections. So this is the symbol that is being used for resistor. Okay, but of course you can use rectangles as well. So this is parallel circuit that involves resistors, and then you have, of course, series. Okay, that involves resistors, but you can rewrite it as like this. Some of your teachers might utilize this convention, which is fine as well. So they're the same. Okay, so resistors, as you can see, I have written it like this earlier. You can write it like that. There you go. So this is of course parallel. You already know that. Okay, let's just use this one. Then you have series here. So you try to not forget the concepts behind series and parallel connections, and of course we're going to incorporate Ohm's law on this solution. As you remember from our capacitance, diba? So we have C equal to Q over V. So this is utilized on circuits because Q is very related to I, right? In fact, I is defined as Q over T. So meaning Ohm's law can be used, and we will be using on circuits. So I think that's it. You may check now your Canvas courses for self-paced, and then for the items that will be having color bands will be discussed to you by your teachers. So that's it. Thank you so much, and once again, good day.